record with Panopto, which is the software that we use for recording lectures. So I've got my cell phone propped up, and I'm going to record on my cell phone on the dock cam, and then upload that recording to Canvas. So hopefully that will work. Because I want to go over what we attempted to go over on Zoom, which I feel like was a miserable fail on Tuesday, of going over testing bits and setting bits and clearing bits, because I think that's a lot easier on paper or on whiteboard. And so that video, because it's not working on Docking, will be uploaded via iPhone, and I just tested. Hopefully it gets the whole piece of paper. But it'll be better than nothing. So we're going to do a little bit of paper at first. Did everyone see the announcement on Discord about the lab? Someone can't join the Discord anymore. I put an update. So a few weeks ago, the link was a link that expired after a week, and now I have a Discord invite that's like should be good forever. So if you try it again, it should work. But if you don't, let me know after class, and I'll post a different invite. So the lab is now due not this Friday, but next Friday at 11:59 p.m. because it's the last lab that we're going to have before exam 2. So that way you guys can have a little bit more time to work. I still allow it to be submitted until Sunday, but I highly recommend you don't do that if you don't want to study over the weekends. What was that? Not selection sort that makes that lab. Yeah. So you'll have a week and a half or a week, a little more than a week and a half to do that set. Any other questions before we get started? I'm feeling rough, kind of warm. I have it on fever, but I'm very light. It's really stuff. Well, it was interesting to see guys who are so quiet on Zoom compared to like the normal roar of the class, and the chat was pretty quiet. And the other class, you're loud enough to hear that it's like, oh, Zoom, so whatever. But the one-on-one class, does not speak. I don't know if they're just intimidated from being their talks auditorium upstairs, and so it's like 900 seats. And I think just being in a room like that is intimidating, no matter what class you're in. It's just really good. That could be good. But they're completely silent, and then on Zoom they're just blah, 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 chatting away with chat box. And I was like, you guys have personalities? This is awesome. Please show it in class. It's just complete silence and stone face. So hopefully there'll be more talking. Alright, so if you haven't, go ahead and get out some sheets of paper or some notes to take notes on, because what we do today, last semester, the students told me that this lecture made the Bitwise lab so much easier. This lecture is very, very, very similar to that lab. So go ahead and grab some paper. All right. So in the file, the certificate file, yes. Can everyone lower the volume so I can hear the question? Yes. We're going to do some coding too, but we're going to write it first. Oh, no, we are not sharing paper. It's a little bit of pieces today. No. We are not doing arts and crafts or anything like that. talked about heart rate, blood pressure, SpO2. I asked you guys what SpO2 was on Zoom, and it was like dead silent. Yes, it is an O2, like the oxygenation of your blood. So when they take your pulse at a doctor's office and they put the little thing on your finger, they also like get the oxygenation of your blood. And if it's good, it's 100%. If at night it falls below 90%, then you might have sleep apnea. So, and then if you're really high elevation, then it'll also drop. All right, so we're going to add one sensor called SC, and that stands for speed cadence, just so we can use 4 bits today. And we represented in code, heart rate will be the 0 index bit is what I'm going to call it, or the ones place. Blood pressure was next, and that was first index bit, or the twos place. SpO2 was the second index bit, or the fours place. And then speed and cadence we're going to add on at the end. The eighth place. All right, so if I have what we called an int my sensors, and that int is currently 1101. What is connected right now? There are 3 sensors connected. What are they?
Heart rate, SpO2, and SC.
Exactly. Heart rate, SpO2, and SC is speed cadence. So we are looking at the far right number as the ones place, and that's what I'm calling 0 index. And this will, I'm using indexes so that will match up with our code a little bit later. So what this is represented though as an int when we print out the int to the screen, what is this in decimal? This number. So this is 8, right? This is the 8th place. This is the 4th place. 13. So if you print out my sensors at any time, especially if we add more sensors to this, like if we have 16 different sensors, I'm like, okay, what is connected right now to my watch? And we print out my sensors, it's just going to print out a number that then we would have to like translate over to binary, and then we're going to look at the bits. And it's very easy to see that when we do it by hand. Like when we see this in binary, it's like, oh yeah, heart rate, blood pressure, speed and cadence. It's very visual. But when we print that out to the screen as 13, it's like 13, I don't really know what is stored in there when I just see 13. So that's why we need functions called test bits. So if we do test bit on heart rate, it'll say yes or no that heart rate is connected. If we need to add, let's say, what are we missing? We're missing blood pressure. If we need to add blood pressure, I don't want to say, okay, let's add 2 to 13 because that's really convoluted in code. We want to make it nice and neat where it's just like add blood pressure, and we're going to do the bit arithmetic in order to do that. So if I have the number 13, like we said, 13 is 1101. And I want to see if heart rate is, let's do SpO2. Again, let's quiet down. Blood pressure. If I were to represent blood pressure alone, remember this is the twos place, so that would be 0010. So blood pressure is 2, right?
So how nasty would it be if we were going to go in code and say, okay, heart rate is equal to 1, blood pressure is equal to 2, SpO2 is equal to 4, speed cadence is equal to 8. Hard coding all of that would look pretty nasty, right? And then if we keep adding on sensors, then something else would be 16, something else would be 32. So we need something nice and neat in order to get the particular bits that we need to represent blood pressure or represent heart rate or represent SpO2. And so that's where the shifting comes in. So remember, this is index 0, 1, 2, and 3. And when we did the left shifting, which was this operator, and then we take the index. Let's take 1 and move it over so many places. So index, or you can think of this as places. So if I take 1 and I move it over 0 places, then what is that going to represent? If I take 1 and I move it over 0 places with that left shift operator, remember what the left shift does is it takes 1 and it can either move it over 1 place or 2 places or 3 places. It depends on what's right here. It's moving it over 0 places right now. So 1 moving over 0 places is still 1. So what does that represent? Heart rate, exactly. So this is heart rate. And then if we shift over 1 by 1 place, that is blood pressure, right? If we shift 1 over by 2 places, that is SpO2. And then if we shift 1 over by 3 places, that is speed cadence. Yeah, so this box will look like 0, 0, 0, 1. This is 1 shifted over 1 place. This is 1 shifted over 2 places. And this is 1 shifted over 3 places. This matches up with the places up here. And so if I have this saved as a variable, and that's what makes it really, really, really easy to make these numbers over here. Heart rate, blood pressure, SpO2, and speed and cadence. Does everyone understand the left shifting right now? All right, so I'm going to move this piece of paper up. I might. So right here. So again, let's say my sensors is 1101. This is my sensors. And I'm going to take this for blood pressure. And I want to check if blood pressure is in my sensors. So remember, my sensors is 13. We wouldn't be able to see that 1101 easily. So this is 0010. Can you guys in the back see that, or should I make my writing a little bit bigger? Okay, so 1101 and 0010. I want to check to see if blood pressure is in my sensors, but I don't want to change my sensors at all. So I just want to see if it's in there or not. So I want to get either all zeros or 1 somewhere as my result. Because if it's all zeros, I can say false, that it's not in there. Or if I get a 1 anywhere, or multiple ones, then I can say this is true. So when we do a test, we want to get a result that's either all zeros will mean no BP in my sensors, and a 1 would be BP is connected. So let's take this and this. And we did talk about it last time of what to do, but think about what we can do and work with the people around you to test that bit. Yes? So since I moved that up, the blood pressure was I have it up on my first paper. I have the blood pressure in the two's place. So if the two's place has a 1 in it, that means blood pressure is on. So the 0, 0, 1, 0 is for testing the two's place. So I'm going to use 0, 0, 1, 0 to test the two's place. And I'm going to use that with my sensors. So I'm going to figure out what operations here is in order to test that. Another question I got is, this is my sensors. And what do we call this? And we can call it a few different things, but what I've been talking about before, we can call it the bit. This is the particular bit we are testing right here. But this number 0010, this is our mask. So when you hear mask, that's what a mask is too. So a mask is a number that we create, like 0010, and we use that number. You can think of it as like a costume mask. We're going to place it over another number to see if this is on or off. So a mask is really just a number that we create that we use for testing. So right now this is a mask that represents heart rate. Sorry, not heart rate, but blood pressure. So if you just needed a name, instead of saying 0010 all the time, what do we call that number? Can we give that number a name? It's a mask for blood pressure. All right. I'm going to make some more room over here. So again, this is my sensors. This is the mask for, we're doing blood pressure, created by this is 0010. So what happens if we let's just go through some different operations. So right now we are testing the bit. And what this means in our application is we are testing to see if blood pressure is connected. When my sensors is 13. So what is true and false? 1 and 0. What is true and false result in? What is false and true result in? What is true and false? What is true and false? So right, if we look at my sensor and we AND it with the mask, if this is not equal to 0, then it's connected. Else, it's not connected. So what I've done is I've taken the master blood pressure, I AND it with my sensors. I kept messing this up. My sensors was plural. And because blood pressure is not in my sensors, that's going to end up as all zeros. And so we know that blood pressure is not connected. Does that make sense to everyone? Think of the mask as placing it over my sensors. Let's see if this lines up. And if we have a 1 in my sensors, where the 1 is for the mask, then it's connected. All right, is this better than Zoom? Yeah. I think so too. I wanted to draw so badly on PS Code, and I was like, this sucks. Okay. All right, so that's how we test a bit. So if you take this, and if we want to have a test bit function, and this returns an integer, then we can have it return what I wrote up here. My sensors and the mask not equal to 0. So remember, you have to make the mask right up here in this line. And how we made the mask we'll go over in just a little bit. We'll do that in the next step. But right now we understand on paper how we can make that mask, right? All right, so is everyone good with testing? Any questions on testing that bit? All right, so we know from testing the bit that blood pressure is not connected to the sensor list. So now that we've tested and it's returned false, let's say I want to add blood pressure. So add a sensor. That's also known as doing what to the bit? Set, test, or clear? Set. All right, so again, my sensors is 1101. And let's use the mask for blood pressure. What would I do to set that bit? So think of the different operations we know. We can use the NOT operator, we can use AND, we can use OR, we can use XOR. So I think I heard it up now. What did you guys say? OR. Yeah. So we can OR this. So I'm going to write this is OR. I'm going to write OR over here in a tiny O and a tiny R, so you just know it's not a 1. So that's the OR symbol. So what's true or false?
True.
What is false or true? What is true or false? What is true or false? True. So now we have 1, 1, 1, 1, which is what we wanted, because we didn't want to remove any sensors in doing the operation. We still wanted to keep heart rate, SpO2, and speed and cadence, but we wanted to add blood pressure this is if we want to add this to my sensors, I can say my sensors is equal to my sensors ORed with the mask. And the mask we're going to create above that, of course, so we'll make the int for the mask above that. And the way we made that mask was 1, and for blood pressure we did a 1. I'm just going to put BP. Alright, does everyone see now that we've done a few, when we're making this mask, to make the mask for blood pressure, we take the bit. So this is the bit that we're going to move around. You can use the left shift operator with any number, like we can have 13 left shift by 1. But we just want to have a whole bunch of zeros and a single 1 somewhere. We want to have a 1 for the blood pressure, or a 1 for the heart rate, or a 1 for the SpO2. So we're just moving a single number around. And this right here is going to change, right? The number of places will move that 1 over. Right here, the part that's going to change, if we're going to change that, it should be a variable, right? A variable changes. And so that's why I have an enum at the very top of the code. So the enum, we briefly talked about, is where we can create a new type, where I typed out heart rate, blood pressure, SpO2, and now we have speed and cadence. And what an enum will do, it will take those 4 words, and the compiler will translate those to 0, 1, 2, and 3. So that way it's just a little bit nicer to read. We could just have it somewhere in our code that, hey, 0 means heart rate, 1 means blood pressure, 2 means this. But that way when we're typing it out in our code, it's a little bit easier to see that heart rate is represented by the 0 place, or the 1 place, the 0 index. The blood pressure is represented by the 2 place, the first index. Any questions on mask? Any questions on adding the sensor or setting the bits? All right, so let's do clearing. So let's remove blood pressure now. So if we want to remove a sensor, that is clearing the bit. So now my sensors is 1, 1, 1, 1. And let's remove blood pressure again. So, we just added it. Do you want to remove something else? Remove heart rate? Let's remove SpO2. So SpO2 is the 4's place. Or the second index. So SpO2 is this. All right, so I want to do operations where this is the mask for SpO2, and I want to end up with, what do I want to end up with once SPO2 is removed? What should that binary number look like for my sensors? Well, I heard 1101. 1011. So what operations can I do? The operations are and, or, XOR, not. And we want to make this work every time. So some people are saying XOR. In the code that we talked about last week, this is the one, or not last week, last Tuesday, this is where we knotted the mask and then anded it. So I'm going to show you guys XOR. Some people are saying XOR. So if we do, hold on, I'm going to do, we've run out of room. All right, so now we're on remove. Sensor 1111. Zero, 1, 0, 0. Okay, XOR. If we do XOR, 1 XOR 0 is 1. 1 XOR 0 is, what is 1 XOR 1? And 1 XOR 1 is 0. 1. Mask for SPO2. So let's do this again for knotting the mask and then anding it together. So I'll show you another way. So let's knot the mask. That is 1 0 1 1. And now we and this together. 1 and 1 is 1. 1 and 1 is 1 and 0 is 0. 1 and 1 is. All right, let's do this with where we don't have my sensors all as ones, just to do some more tests. Let's do 0 0 1 1. And let's remove SPO2 still. So this is my sensors. If my sensors is 0 0 1 1, what is connected? Blood pressure and heart rate. So my sensors, I'm changing my sensors to be blood pressure and heart rate. If I want to remove SPO2, then I want my sensors to stay the same, right? So this is for SPO2. If I do remove sensor, then I should have 0 0 1 1 still. So let's test this out. Even if I remove a sensor like SPO2 that didn't already exist in there, nothing should change. All right, so let's do the XOR first. 1 XOR 0 is 1 XOR 0 is 0 XOR 1 is 0 XOR 0 is. Is there a problem here? Yeah. So the XOR doesn't work for removing a sensor because of this error where if we try to remove something that already is not in the sensor list. So we can use XOR if the user is very aware of what is connected and what is not. And we know SPO2, for my sensors. But remember, my sensors were just given that as like a random number, like 13. Period of 13, it's like, I have no idea if SPO2 is in there or not. We have to use the test function for us to tell us. Because remember, 13 could be like 272, and you don't want to have to take that apart and look at it visually. So the XOR works if we test it first, and we know that it's in there and it needs to be removed. But right here, this is where we run into the problem where we use XOR and we're trying to remove it, but we accidentally add it instead. Does everyone see this? So the XOR can work if, I'll write this down here. XOR can remove the sensor if we know for sure it is connected. But if we remove a sensor, if we use XOR to remove a sensor that is not connected, then it will actually add it. Okay, so let's do this example again by knotting the mask and anding it. So my sensors, 0, 0, 1, 1. And SPO2, remove. Okay guys, let's quiet down. 0, 1, 0, 0. If we knot this, that's going to be 0, 0, 1, 1 and 1, 0, 1, 1. And this is my sensors, and now knotting the mask. What is true and true? True and true. False and false. False and true. Does this work? Yes. So the way to remove sensors or to clear a bit, where you know you're going to clear the bit even if it already is clear, is by knotting the mask and then anding that knotted mask. So first you do the mask, then you knot. First you knot the mask, then you and the knotted mask. So the way it's a little bit easier if we write it down. We knot the mask. And then we and that with my sensors. Yes, sorry about that. Any questions on clearing the bits? All right, so the way that we could write that in code, where'd my pen go? Yes. Knotting the mask splits all the bits. So when you knot the mask was 0, 1, 0, 0. And when you knot it, you flip all the bits. Yeah. Yep. We switch every 0 to a 1, and we switch every 1 to a 0. Yep. That's, yep. Yep, exactly. Yep, so really not any binary number, that's just flipping all the bits. Alright, so the way we wrote this in code was, I'm going to write the function definition up here for the sensor template that we had. I'll write it down a little bit over here. We had void, clear bits, and that took a sensor type index. And so in order to clear the bit, I'm going to go over the argument in just a second and the return type, but I need to know how much paper I'm going to take up. So I made a mask, and that was left shifting the index here. So the index is going to be either 0, 1, 2, or 3. Where 0 represented heart rate, 1 represented blood pressure, 2 represented SpO2, is that right? And 3 represented SC, yes. So I created an enum called sensor type, and that just says anywhere I write HR in code, change that to 0. The compiler's just going to take HR and replace it with 0 anywhere, and that way it's just easier for us to write this code and look back at it later. So we have the enum at the top. Enum sensor type. And we have HR, BP, SpO2, and then speed and cadence. And then we had commas, and then I had an ending parentheses, semicolon. So again, what this does is replace HR with 0 anywhere in the code. Because of the way enums are made, I don't actually have to tell C++ that heart rate should be represented as 0. It's just the first thing in that list will be represented as 0. The second thing in that list will be represented as 1 because we're 0 indexed. So if you wanted to create your own enum and we wanted to have more sensors, or if you're going to create an enum for code in a lab or any other code, the enum will automatically take HR or whatever you have as the very first thing in your list, and it will replace that with 0 in your code. And again, I'm just doing this so it makes it easier to read when we do these functions. Alright, so when I do sensor type index, let's say I call this in, so here's main down here. I call this in main as clear bits. And are we clearing SpO2? I know you can't see that, so I'll move that up. When I call clear bit SpO2, then the compiler will take SpO2 and replace it with number 2. If I call clear bit BP, it'll replace BP with the number 1. What I'm going to use that for is I'm going to use that to create my mask. So this is saying, hey, clear SpO2, take this number and I'll use it to make a mask for SpO2. If I'm going to add BP, I don't remember what to call it, add bit or set, it's probably set bit. If I do add BP, it's going to, in the compiler, we'll change this to add and BP is 1. So 1 will be passed here, this will be clear. SPO2 is represented as 0, 1, 2, 3. Clear 2. All right, so up here, here's where I am writing my clear bit function. So let's say 2 is passed. So the mask will be one left shifted by 2, which is what we did on paper before. Does everyone see that? Because we passed 2, which I've nicknamed, you can think of it as a nickname, as SPO2, I can now make a mask right here that represents SPO2. And then the clear bit was what we did last over here. We knotted the mask and then we ANDed the result with my sensors. So my sensors is equal to my sensors and not mask. And that is it for clear bit. Remember, my sensors was part of the class, and that's why we can access my sensors in this function. Does anyone have any questions about how we write that in code? All right, should we move on to how we write that in code for, let's do set bits next. So this is adding, this was actually set. So we had a void function that was set bits. This also took sensor type index. And remember, the argument here for this function, the parameter, is only used to make the mask. So we just need, okay, what type of mask do we need to make? Tell me what sensor that is, and I'm going to pass it in right here. All right, for set bit, what operation did we use? And, or, XOR? We used OR, exactly. So let's make the mask. So int mask is equal to 1, and we left shift it by the sensor that we passed in. And then we used OR. So my sensors equals my sensors ORed with the mask. All right, so I'm just drawing a line to separate the functions here. All right, I'm going to put wait, sorry, I've started writing in the wrong spot. Okay. My sensors equals my sensors ORed with the mask. I just saw code right. Okay. On 1 second. lab and code. Any questions so far? Are you guys following along? Is this better than the Zoom on Tuesday? Yeah, okay. Let's do the very last one. So we've done remove, which was clear. We've done the clear bit, we've done the set bit. What is missing? Test bit. So if we're going to test BP, what does test bit return? Is it a void function? No, it needs to return true or false whether that sensor is connected or not, or in your lab whether that bit is set or not. So when we test a bit, we want to return true or false. So clearing was a void function, setting was a void function because we were just changing something in my sensor's test. Needs to return true or false. False being a 0, true being anything other than 0. All right, so test is the first thing that we did over here. Let me pull that back up. So I'm going to have this return not a Boolean, but an int, because in C code, this is very low level stuff that we're doing, manipulating bits like this and using an integer to store. So typically you would only be doing this in a language like C, or you'd want this code to be able to be converted to C easily, and C doesn't use Booleans. Really they use integers as true or false. So if an integer is 0, it's false. If it's anything other than 0, it's true. So just to keep that in mind with what you'll see in operating systems and with systems programming, I'm going to have this return an int, where it's, like I wrote down here, false is 0 and true is anything other than 0. All right, so int, this is test bit, and in the lab, I think it's called bit set, and that's what I have in the sensors. 2. I'm going to take sensor type. Index, this takes the exact same parameter. Oh, int mask. Can I make the mask the same way as I did with setting the bit? Can I make the mask the same way? Yes. All right, and when we did testing the bits, this is what we were writing earlier above the squiggly line. I had my sensors, and then I had a mask for blood pressure. And up here in my sensors, we can see with 1101 that blood pressure wasn't set by just looking at it visually. So when I created a mask, I needed the result to be all zeros when I do an operation with my sensors and that mask. So what we did was we ANDed, pull that over here. So we took my sensors and we AND that with the mask. How do we make that into a return value that's an integer. I wrote it up here earlier. It's going to return true if there's any ones. Actually, wrote it right here. Exactly. This is what I had up earlier. My sensors and the mask, if that is not equal to 0, then it's connected. Else, it's not connected. So what I'm going to return, my sensors and mask not equal to 0. If this expression is true, then it will return 1. If it's false, it's going to return 0. I'm going to do a parentheses around this, just to be very clear that we're going to do that first. Yes?
This isn't being written inside main, correct?
No, these are functions that we're writing above main or below main, but they're class functions. All right, any other questions on this? 15 more minutes. Do you guys feel like you can go back to the sensors template and get it to work? All right, so let's pull that up, the sensors template. Yes. Yeah, just because I didn't have to remember. It's just, yeah, I had a name. I was writing name somewhere here, and I had to write it below just because of where I had the people located. Yeah. Yeah. The way I wrote these functions in relation to name was just because of the space I had on the paper. It's not necessarily where you should actually write them in relation to name your code. All right, I'm going to write down a few more things and then pull up this. So this main was just a very scratch paper-esque type main, where the other stuff was more legit code. All right, so in main, this is less scratch paper type main, but in actual main, I had a sensor list. My watch, I probably could have come up with a better class name for that. But sensor list, remember, was the class that we had, and this class had my sensors as a member variable. And just as a review from 101, my sensors was a private member variable. So can the main function access my sensors? No, because it's private. So sensor list is a class. It had my sensors, and this is where we had all of the functions, like we had the set and the clear and the test as functions as a part of this class. And set, clear, and test could access my sensors because they were functions that were part of that class, the class called sensor list. So these were public member functions. Okay, so I made an object called my watch. So my watch can connect sensors to it, and I just want to make sure that we can call these correctly. So my watch dot get my sensors. What this does is it just prints out a number, and it prints out the int my sensors. Pretty sure, let's see, I think I know how to print. Oh no, it doesn't print, it returns, sorry. Just looking. So if we need to know what my sensors is in main, then we use that accessor function. Do you remember in 101 in Java we talked about getters and setters? So this is a getter function. So we can just get my sensors if we need to access it for whatever reason. And then we use the dot set, dot clear, dot test, just like Java with the object. All right. Any questions? I'm going to hop over to the computer. It's going to take a second. But let's load up that template.
Makes me wish I had VS Code.
What did you say?
I said this makes me wish I had VS Code.
Oh, yeah. All right.